Linear measure has to do with distance or length. We would like to convert 60 miles per hour to feet per second. This diagram is called a square diagram, a box. So you put in these little boxes, you put the numbers. You put the one that you're converting from, the original, you put it first. Then you have to find out which numbers you should put here so you could cancel the miles in the hour, end up with feet per second. So we would have to know that 5,280 feet equals 1 mile. Notice if I put the miles in the denominator, I could cancel the miles, and now we have feet. Then we want to cancel the hours. So the next little box in this box diagram, you put 1 hour equals 60 minutes. So you could cancel the hours. These hours cancel. Then you want to cancel these hours and go to seconds. So you keep going until you get what you want. So how can I cancel these hours? Well, 1 minute equals 60 seconds. These hours canceled already, but now we have to cancel the minutes. So this minute cancel this minute. This hour already canceled this hour. So you only have feet and seconds left, which is what you wanted. So the top you multiplied straight across, the bottom straight across. It's like multiplying a fraction times a fraction times a fraction times a fraction, and you get 88 feet per second. The metric system is an easier system to use because you don't have to memorize that a foot is 12 inches or 3 feet is a yard. You don't only memorize the scale once. You only memorize the scale. The scale is the same for the meters, grams, and liters. The only thing that's going to change is the unit. These are meters, these are grams, and these are liters. Everything else stays the same. If you move in that direction, every little hop counts for a times 10, times 10, times 10. If you go in this direction, it's divide by 10, divide by 10, divide by 10. So 1 decameter is 10 meters. 1 hectometer is 10 decameters. 1 kilometer equals 10 hectometers. You do the same with all of these. Just move the decimal. So let's practice using the metric system. Here's the scale. We're working with the meter, right? So we would like to know what 0.03 kilometers equals in centimeters. So locate where you are. We're at the kilometer place, and we want to go all the way to the centimeters. So we're going to have to move 1, 2, 3, 4, 5. There are 5 hops. So this decimal is going to hop 5 times. 1, 2, 3, 4, 5. This is the new location of the decimal. So 0.03 kilometers equals 3,000 centimeters. We're still with distance. Now we're going to look at these two terms. This is collinear points and not collinear points. Collinear points means that one line contains them all. Non-collinear points, one line does not contain them all. If you're going to measure the distance from one collinear point to the other, it will plus distance BC will equal distance AC. So AB plus BC equals AC. Makes a lot of sense. Over here, something's going to change when they're not collinear. Notice the AB, BC, and AC are still there, but this time the relationship between distances is different. In this case, when they're not collinear, distance AB plus distance BC is greater than distance AC. So if these were 3 buildings where you work, you'll get quicker to point C if you go directly from A to C instead of A to B and B to C, since AC is a smaller distance. This is called the triangle inequality. Is a distance idea. perimeter has to do with the distance around. So you just add all the numbers around. It doesn't matter where you start. So if you add all these numbers, all these distances, the perimeter would be 107 centimeters. Circumference is a perimeter. But when you say circumference, someone would know, oh, you're talking about the perimeter of a circle. So circumference goes with circle. It's the distance around the circle. It has a formula. There's two ways you could write the formula. Notice these two formulas are related because 2 radii makes 1 diameter. So use whichever one you like. So for this circle, if the radius is 3, you plug it in where the r is. So this would be 2 times 3 is 6. So the circumference for this circle is 6 pi. This is exact. This is an exact answer. And this one is an approximation. That's why we have this squiggly equal signs. It's an approximation. And these are units also. They're 6 pi units or 18.85 units. Now we go from distance to areas. Areas are like surface. How much surface do you have? So areas of polygons and circles. When converting from a unit into another unit, that means from square centimeters, square meters. Before you do the conversion in the area, first go to the linear relationship. So notice 1 foot equals 12 inches. Now, if you want to use this for area, take it, square both sides, raise each side to the second power. So this is 1 square foot. This is 144 square inches or inches square. It doesn't matter. So you could tell right away if your units are to the second power, you're working with area. If your units are to the first power, you're working with length. The area of a rectangle has a formula. So we're going to be seeing a couple of formulas. So once you have the formula, if you know what these variables mean or these letters mean, you're done very quick. You just plug things in. So if we have a rectangle here, notice the rectangle has a 90-degree angle all around. You can call this the length and the width, or you can call this the width and this the length. It doesn't matter. You're going to multiply them and get the same area. Here's an example. So here's the width, here's the length. Multiply them. So it's 5 times 3 is 15, and inch times inch is inch squared. So the surface of this rectangle, the area, would equal 15 square inches. The area of a parallelogram, notice a parallelogram, it has the word parallel. These little arrows you see here, the ones that have the same number of arrows are supposed to be taken to be parallel. So these two sides are parallel, and these two sides are parallel. That's why we call it a parallelogram, because the opposite sides are parallel. This is the formula for the area of a figure like this. It's the base times the height. Now notice the base or the extended, in this case it's the extended base, is always perpendicular. This is a symbol for perpendicular to the height. Anytime you mention a height in any formula, perpendicular has to be there. The 90-degree angle has to be there by definition. Now we have the area of a triangle. Notice how we label the triangle. Notice that there's 3 places, 3 ways, or the height for 3 different types of triangles. This is probably an acute triangle, this is a right triangle, this is an obtuse triangle. And notice the height is always perpendicular by definition. So once you identify the base, which will be one of the sides of the triangle, and identify the height, all you have to do is multiply them and divide by 2. And you have your area of that triangle. This is the area of a kite. This D1 means diagonal. It's like the diagonal of your TV, right? It goes from one corner to the opposite corner. They're diagonals. This is a diagonal. This is a diagonal. If you know their lengths, all you have to do is multiply them and divide by 2, and you get the area of the kite. The area of a trapezoid. What's a trapezoid? Well, a trapezoid has a pair of parallel sides. One pair of parallel sides. So the ones that you call bases are parallel. So base 1 and base 2 are parallel. By definition, that's a trapezoid. So this is base 1, base 2. Notice the height is the one that joins the two bases perpendicularly. So all you have to do is identify your height, the two bases, you add them, then multiply times the height and take half. Area of a regular polygon. So this is a polygon. And notice what the formula for the area of a polygon is. You want to know how much area there's in there? It's 1/2 the apothem times the perimeter. Apothem sounds like an animal name, but it's the distance from the center perpendicular to one of the sides. That's called the apothem. And then if you know the perimeter, distance around, all you have to do is multiply them, take half, and that's the area of the polygon. Now we have the area of a circle. This is a formula for the area of a circle. All you need is to know the radius. The pi is part of the formula. So if you know the radius of the circle, then all you have to do is square the radius and multiply it times the pi. So if you know the radius, you could find the area of a circle. How about the area of a sector? Notice how this is cut off. It's cut off the way we usually cut the pizza. When you cut something in this form, this is called a sector. So we're going to find the area of a sector, which is a portion of the area of the circle. This is the area of a circle. So you're going to take a fraction of the area of a circle, a fraction of the area of a circle. This is theta, a Greek letter for angle, theta. How many degrees is it from here to here? Well, that's how many degrees out of the 360 possible, right? It's the fraction of a complete rotation. That fraction of that circle will give you the area of that sector.